Hey, fourth graders, this is another math lesson for you. This is page 255 to 256 general review. Nothing new to show you guys, but I wanted to just go over some questions that might be a little bit confusing and show you some example questions. So a lot of times I won't be doing the actual question, but I'll do another question that's very similar to it that will help you solve the question. All right, so for example, number one, write the number for each number word. The first question says $6.47. So we have to write this as a number. I'm going to do an example question here. $5.24. So what you would need to do, write 5, and since it's a dollar, since it's in dollars, I need the dollar sign and decimal point, 24 cents. All right, so that should help you solve this question here. Next one says 8 3/100ths. So important thing to note here is that it says 8 3/100ths. All right, hundredths. All of these have hundredths at the end. We know this means that this is a fraction. Okay, so it's not 8 3/100, but 3/100ths. So our 3 needs to be in the hundredths place. If you guys remember, our place value for decimal numbers, first one is tenths, then it's hundredths, right? Hundredths. Let me write it somewhere else. So if you guys please remember decimal point here. So tenths, then hundredths, then the next was thousandths, right? Okay, so this problem here, here's an example problem. 39 6/100ths. So I would write 39, and I need to write 6/100ths. Since it says 6/100ths, that means should be in a decimal, should be in the hundredths decimal place. So what's the hundredths decimal place here? It's the second decimal place, right? Yeah, so it needs to be 0.06. 39 6/100ths. Yes, so 6 is in the hundredths place now, right? So this is tenths, and this is hundredths. All right, so for this problem, whenever you see the word and, you know that's where you need to put the decimal point. All right, let's go to the next one. Write each as a mixed decimal. This is 13 4/100ths. So it's very similar to our first problem here. You write 13, so 13 whole numbers. And to write this fraction here, we put a decimal point, and 4/100ths. So 4 needs to be in the hundredths place. We know the hundredths place is the second place here, right? Well, here, a trick you can do, a trick you guys can use is see how many zeros there are. 2 zeros, so 2 place values here, and the 4 needs to go in the hundredths at the end, and we put a 0 here, so 13.04. Okay, so I ended up doing a problem for you. Okay, so here is some more example problems. 18 3/100ths. So write 18 decimal point, and to write 3/100ths, we need 2 place values because we have 2 zeros here, and write 0 3. The 3 is in the hundredths place. Okay, yeah, this is tenths and 3/100ths. Okay. All right. Another example question: 26 5/1000ths. 1,000ths. All right. So 26 decimal point. The 5 needs to be in the thousandths place, which is 3 place values to the right. We have 3 zeros here, so 1, 2, 3. 5 goes at the end. Fill in our zeros, and yep, 26.005. Okay. Yeah, because now our 5 is in the thousandths place, right? Thousandths. I can't fit it in here. All right. Anyways, divide and check. Divide 37 into 19,742. You guys know that I like to round my numbers to make it easier. Can 4 go into 1? Nope. Can 4 go into 19? Nope. Can 4 go into 197? Yeah, probably. So, how many times can 40 go into 197? Instead of looking at it as 197, you can round it up to the nearest tens place, which is 200. So ask yourself, how many times can 40 go into 200 without going over? Well, I know that, 4 times 5 equals 20, right? So 40 times 5 would be, so 40 times 5 would be 200, right? So probably 5 would be a good place to start. So let's try out 5. 5 times 37 is 185. Subtract that. I would get 2, 1, 12. 12 is less than 37. So bring down the 4. How many times can 40 go into 124 without going over? Well, I know that 40 times 3. Okay, so I can round this to 120, right? I know that 40 times 3 equals 120, so 4 would probably be a good place to start to see if it'll work. 4 times 37 is, let's see, 4 times 37 times that, 28. 4 times 3 is 12, 14. It's 148. Oh, so is 4 the right answer? Can I subtract 124 minus 148? Nope. So I know this is way too high, so it needs to go lower. So I need to try 3. So let's try 3 times 37. 3 times 7 equals 21. Plus 3 is 9. Plus 2 is 11. 111. Subtract that. I will get 13. 13 is less than 37, so I'm good. Bring down the 2. Now ask yourself, how many times can 40 go into 130? All right. Well, I just did. I could try 4 again. Sorry, 3 here. So I can try 4 again, but I know that 4 times 37 equals 148, which is way too high. So I should probably try 3 again. 3 times 37 is 111. Subtract that. 1, 2, 21. So 21 is less than 37, so I'm good. So it's 533, remainder 20, remainder 21. Remainder 21. Hold on for a second. Remainder 21. Okay. All right, let's do a review. Change to a mixed number. So these are all improper fractions. All right, so let me do some example questions here. When we have an improper fraction, we know that we need to do long division, right? Divide the denominator by the numerator. So 4 divided into 8, 2 times. 2 times 4 is 8. Subtract that, 0. So this is 2, just 2. Now let's do this one. 17 over 6, improper fraction. Change it to a mixed number. 6 goes to long division. 6 goes to 17 2 times. 2 times 6 is 12. Minus that, remainder 5. So 5 is our numerator. What's our denominator? It's this denominator here. So 2 and 5, 6. All right. Fill in the blanks. This is a little bit trickier. 1 kilogram equals how many grams? So really important. Since we don't have that poster nearby, you need to turn to page 348. On 348, you would see this here. This here is going to help you guys a lot in answering these next set of questions. So let's see. Let's try to get them side to side. All right. So 1 kilogram. Sorry. So 1 kilogram equals how many grams? So over here, we can look at our table, look for the grams. Okay, so grams measuring weight, grams. All right, so it's asking us 1 kilogram equals how many grams? So look for kilograms, kg equals how many grams? Okay, I'll let you guys figure that out. All right, so yeah, 1 kilogram equals 1,000 grams. So that's very straightforward. Here's the next one. It's asking us how many grams are there in a milligram, mg. If you look at our chart here, you would see milligrams here and grams here, right? So does that mean there's 1,000, 1 and 1,000, 1/1000th of a milligram and 1 gram? No. Is that what this chart says? No. This is 1 milligram equals 1/1000th of a gram. So I can't write 1/1000th. So what do I write here? Well, you have to think of it the other way. So what would be the opposite? If 1/1000th of a gram equals 1 milligram, how much does 1 gram equal? All we need to do is just look at the denominator here, 1,000, and just write it here, 1,000. So there's in 1 gram, there's 1,000 milligrams. So you get to, since this tells us, this goes from milligrams to grams, and that's not what we're looking for. We're looking for grams to milligrams. All right, so it's 1,000, not 1/1000th. So just make sure if it's, going the opposite direction, if the base unit starts first and then it's asking you to convert to a different metric unit, then you have to switch it, kind of look at a different direction. I know it's kind of confusing, but E is also another example. It goes from 1 meter to centimeters. Here we have centimeters to meter. So I can't write. So 1 meter does not equals 1/100th meter. So what is it equal to? Okay. Yeah, same thing for F. All right. You might be wondering why this is. There's a different way to think of it. You can think of it as, you guys all know that 1 penny represents, if I would try to convert 1 penny to a dollar, I can say 1 penny represents 1/100th of a dollar, correct? Yeah. So my question is, $1 equals how many pennies? Obviously, you wouldn't say 1/100th, right? You wouldn't look at this chart and say, okay, since 1 penny equals 1/100th of a dollar, then $1 equals 1/100th of a penny, right? No, that's totally incorrect. So instead, I would say $1 equals 100 pennies, right? Okay. So same thing here. Let me erase this. So 1 milligram equals 1 milligram equals 1/1000th of a gram. So I can't say 1 gram equals 1/1000th of a milligram. No. I need to think of it as the opposite way. Flip it around. All right, just like dollars to pennies. All right, so instead I have to flip this around. So now it will be 1 gram equals 1,000 milligrams. All right, if you don't understand that, it's fine. I know that kind of went a little bit long on that explanation. Hopefully that helps you. Just go to page 348. That's going to help you. All right. Next one. Use a ruler to measure these lines. Measure to the nearest ½ inch. Really important that you measure to the nearest ½ inch. Okay, ½ inch. So if it's, not exactly past the 1 the see, it says, so if you measure, imagine this is ruler here. If you measure this, and let's say the line stops a little bit past the half-inch mark, then you would say it's 3.5 inches. Okay, yeah, even though it's past the half-inch mark, you would write it down as 3.5 inches. Same thing if it's really close. If it's closer to the nearest, if my line was here, if my line ended here, why is it doing that? All right, sorry. All right, whatever. Right. If my line, let's say my line was like this long, it's past the half-inch mark, but not touching the next whole inch, you would just write it down, round it, and you would round it up to 4 inches. Number 7, draw a thermometer for for these temperatures. The first one's done for you. So it's 65 degrees, so they drew a thermometer. And we know that these are going by, skip counting by what? By 2, right? Each one of these is 2 degrees. Okay. So to represent 65, they went to see. Sorry. It's kind of weird. Okay. So to represent 65, they had to skip count. So here, let's do it this way. So we know this is 60 here. So this is 62, since they're skip counting by 62 degrees. 64 degrees, then 66 degrees, and then 68. And at the very top is 70 degrees. So to represent 65, there's no 65 here, but we have 64 and 66. And we know that between 64 and 66 is 65, right? Yeah, that's why the red line stops here. We would need to do the same here. You would need to create your own thermometer. All right. And since this is 14 degrees Celsius, I should probably start at 10 and end at 20 degrees. All right, and then I'll draw 1, 2, 3, 4, 5 lines. All right, sorry, I mean 4 lines. And each of these represents 2 degrees, so this would be 12 degrees, 14 degrees, 16 degrees, 18 degrees, okay? And then, yeah, you should be able to do the rest by yourself. Same thing for all these two, for 20 degrees Celsius, you would probably draw something similar to this. For 72 degrees Celsius, what 2 tens digits would I have here? For 65, they started at 60, ended at 70. For 72, where do you think I should start at? Where do you think I should end for my thermometer? Okay, I'll let you guys figure that out. And the rest, I think you guys should be able to do by yourselves. Okay, so number one, let's do this word problem. The Waller family spent $15.31 on ice cream. Sorry. $15.31 at the ice cream castle. Mr. Waller gave the clerk a $20 bill. What coins and bills did he receive as change? It's a little bit tricky. So he spent $15.31. He gave $20. So what would his change be? Okay. Make sure you give the least amount of coins, and also, yeah, just make sure you don't, you also have to say, what coins and bills. So if you're giving, don't say you're giving 10 pennies, right? Instead of 10 pennies, you can give 1 dime, right? Yeah. All right. So that's pretty much it. If you have any questions, yeah, feel free to contact me. Take care.